The principle of electric motors, which I never understood until I graduated, turned out to be so simple. If my teacher had taught me this, I would have gotten into Harvard. When we bring in two magnets, they will have an interaction force, that is, opposite poles attract and same poles repel. Then we took one of the magnets and drilled a hole in its center and inserted a shaft so that it could rotate freely. When another magnet is brought close to it, the magnet with the hole drilled in it will rotate rapidly until their poles are reversed and they are attracted to each other. If we change the orientation of the magnet at this point, the magnet with the shaft will rotate half a turn again because of the repulsive force. As long as we don't get tired, we can keep changing the orientation of the magnet so that the magnet with the shaft will keep rotating. Next we get a bolt, wrap a few turns of insulated wire around it, connect the ends of the wire to a power source, and the bolt becomes an electromagnet. The same phenomenon of opposites attracting and same poles repelling occurs when we bring the previous magnets close together. If we exchange the positive and negative poles of the power supply, the polarity of the electromagnet will flip accordingly. But it is too much trouble to repeatedly exchange the power supply, then we will try to switch the connection of the wire. The same can be realized N-pole and S-pole switching. We also drill a hole in the center of the bolt and insert a shaft. Then energize the coil and the bolt will rotate half a turn because of the magnet interaction force. As long as we don't get too tired and keep switching wires, the bolt will keep rotating. But to save energy, we change the magnets on both sides to a curved shape, and replace the wire wound bolt in the center with a metal loop we call an armature. As soon as the power is applied, the armature will also start to rotate. But switching the wires manually was still a pain, so we turned the wire connections into curved pieces of metal separated by a slit in the center, which we called the commutator. The sides of the commutator are then fitted with brushes with springs inside to ensure that the wires make contact with the commutator. When the brushes are energized, the armature begins to rotate and the brushes switch contact points as they pass through the gap. Since there are two brushes switching on both sides at the same time, if the current in the armature flowed in this direction before switching, the direction of the current will be reversed after the brushes switch the contact points. This means that the polarity of the solenoid is constantly switching to keep the armature rotating continuously, just as we would switch wires manually, which makes it much easier for us. However, the armature with only one coil of wire is not smooth enough and is prone to stalling, so to increase efficiency we add more armatures to it and install more commutators so that a motor is made. In order to improve its service life, we also added fixing devices, and this is the motor we use in our daily life. Now do you understand?